A sample of 100 tyres of a particular brand that have worn out were taken, and the distances for which they have been used was averaged. For this sample, the average lifespan was 50,200 kilometers with a standard deviation of 800 kilometers. We want to construct a 95% confidence interval for the lifespan of the tyres based on this sample of tyres. So, we have 50,200 as the mean, and we want to go either side of that. So we're going to use K sigma over root n in the usual sort of way. Now in this particular case we're after a 95% confidence interval. So getting the correct value of K is a case of using the inverse normal, going for the centre and going for 0.95. Don't change these parameters because we want the standard normal. So it's going to be negative 1.96. So we're going to use 1.96. So that's going to be 50,200. Take away 1.96 times the standard deviation over the square root of 100, because that's the n. And 50,200 plus 1.96 times 800 over root n. Now of course once we've got that, we don't actually need to calculate it from here. We can just go to the calculator and go into interval, and we want variable and confidence level 0.95. Our sigma is 800. Our mean is 50,200, and we've got 100 in the sample, and so that's 50,043 up to 5357. Explain what the confidence interval means. It means that we can be 95% confident that the population mean is in this interval, in this range of values. How many tyres would need to be in a sample of these tyres so that a 95% confidence interval would have a total width of 200? So a total width of 200, so if this is 200, means that we go up and down by 100 from the centre. So we want K sigma over root n to be equal to 100. So the K value is going to be 95% confidence interval. It's going to be the same value we used before, so we use 1.96. The sigma won't change, so we need this, and rearranging that gives us root n is 1.96 times 800 over 100. So that's just going to work out to be 1.96. I'm going to use a more accurate figure actually since it's sitting here. So that multiplied by 8. So I'm going to say root n is 15.69 and so on. It's actually 67. And so on, and obviously that's root n, so we need to square to find n. So we want this squared, which is 245.85 and so on. So we'd say that x is equal to 246 because it must be a whole number. It's the number of items we're taking.